Hello everyone, in this video I'll be giving you a brief overview of our self-managed ELK stack environment and how it integrates with Azure Kubernetes cluster. We also touch on how DNS is configured to resolve internal services and how application gateway is used to securely route internal traffic. And you can see on the screen we have Azure Kubernetes cluster, which is used to host our containerized applications where logs are collected and forwarded to our self-managed ELK stack here. And we got here the ELK stack running the separate subnet, allowing us full control over performance, upgrades, and security. And we got some DNS. You got see here, you got some private DNS and public DNS. And with its private DNS, we use to resolve the connection between the log task here with the phone with agent we got here in the Kubernetes cluster here. And we have some application gateways. This is the main portal. We use this application gateway combined with the public DNS to expose our ELK stack using this subdomain. And also we have another application gateway is used to expose our front-end application combined with here another public DNS with using the subdomain devops.inetserver.com. And we mainly use to test the ELK stack by using this subdomains for UI connection into our service running in this AK cluster. And we also monitor the ELK service, how it's running and how logs in the Kibana service, which using this subdomain. In the next part of the demos, I'll show you how these pieces fit together in practice, focusing on how log flow from AKS cluster to the AKS ELK stack, and how application gateway and also DNS comes into play for a similar asset. But before we get started, I would like to show you some overview about the integrations with minimal connection between the cluster and how to integrate the ELK stack with the cluster we are working on. And you can see on the screen we have some use case for the integrations between Elasticsearch, Kibana, and also Lotus. And this is the use case ones. So that means we can use the phone bit to directly to forward the log directly into the Elasticsearch, and we can use Kibana to visualize the service, the logs, which is indexed by Elasticsearch. And with this diagram, you see the phone bits calls can now log from a cluster and send them straight to Elasticsearch. And this advantage is it is very simple, libraries and efficient. It creates for you only you need the minimal local processing, and but it gets some limitations, such as no advanced parsing or complex routing before indexing. You rely on Elasticsearch ingest byline for any transformation. So that means with this model, you rely on Elasticsearch. So here is the second use case, which you can use fluently combined with for Fluentbit to collect the log, and you forward the log directly into the Elasticsearch as well. So with this UK, you can see the phone bits handle lock skeleton in on each node. You can see, assume that you see here we got multiple nodes in our IK collector and Fondy. It handle the lock skeleton on each node, forwarding lock to Fondy, can which then send them to the lock task. Send them, sorry, and send them to the other district. With this model, we can combine the phone D and phone bit can work together, and phone bits remain lightweight on the node, while phone D or running additionally can perform more uh, sophisticated filtering, routing, and also enrichment. This models, I think it got limitations such as small moving parts used to rely on most on 4D for work advanced transformation, but you keep the extra flexibility or lock tasks. And here the another advanced parallel with lock tasks. This is also the model we are going to make the most for us today. And you can see on this on the screen we have Flumbit is configured running on each node of the AKI cluster, and Flumbit will take a role to collect all the AKI log and it's report into the log task. And also, if we have the multiple nodes here, it's run in the daemon set, and it take a role to collect all the AKI log. This means the log of our application, and it's put into the log task, and the latter attaches responsibility to push all the formats log the data into Edison for indexing, and then we can use Kibina to visualize the logs on the dashboard. So in this case, why we use log tasks? So we use log tasks for advanced processing. Log tasks can rich plugin ecosystems like Grok or Filter for structures, parsing, enrichment, and routes of logs. And suppose you makes many complex workflow. You can handle multiple input sources, conditionally transform logs and event split or combine data streams. It also supports separation of concerns. Fluent with remain lightweight for node level log collection, while log tasks running gently handle heavier process tasks. Uh, in summary, I think it's approach balance simplicity, the best processing power, direct flow bits to editors in lightweight and straightforward. Flow-based plus Fluently add more moderate filtering capabilities, while Fluentbase allow that provide the most powerful parsing and enrichment features, ideal for a complex environment and multiple multi-stage log workflows. And now we jump into the demo part. Some component here are temporary disabilities to set costs, and also we just enable some module is support for our ELK stack setting demo only, and we also use Terraform to repositioning the infrastructure for all those kind of the components. Now you can see here on the screen, I have the Terraform, the modules, and we have the data environment here. We got the main modules is used to call all the child's modules. we got in the process. We got a link at the module here in this the domain of the ELK modules. We are going to perform two provisioning for our testing for today. And now I'm trying to zoom into the AACs with the environment. I can try to run to the form, apply, that's that out to approve, and press enter. So this process will be provisioning all those all the component we got here. And maybe it's like about 20 minutes to be completed. I'm going to host the post the video for a while, and we will back after all thing is complete. All right, now you see in the total we have 45 components to be added into our cloud service, and we're keeping to wait until it is completed. So whilst waiting the process to be completed, I would like to show you guys how the config we need for integrations between Elasticsearch, uh, Kibana, and also Lotus. So you know because multiple component here, and we got pull bit it uh, collect the log test and it's put all log into the editor, and then Kibana will reuse the data in the editor to visualize on the dashboard for the log we got. Store in our AK cluster. So that means you have the dedicated configuration for it. You will see we got in this is very simple for testing only, but actually in our real environment we need to make more complex configuration for it. And now for the testing purpose, we just try to make them connect together. And you can see here we try to enable the template like this. And also in the phone bit, we also have some templates with this. We got the input data, we got a filter, and we got output, which the output log which collect from our AK cluster, and we put into the logtags server. Also here we got a Kubernetes configuration with like this. Of course, you see here the Kubernetes is connect directly to the editor. So this is why the reason why we got this in the sub IP address with the dedicated port like this, and also we got Kubernetes running on port uh, CC 5601, and here the default for the connection come in. And also we can all start configure configuration terms, and also the same is in this sometimes we call it the byline. So we have to set a byline to follow that it recognize the connection that support him to make a to resist the incoming traffic and send back to the Elasticsearch cluster. And you will see here the default connection we got for log task code. You see the here log task is put the log directly into the Elasticsearch, and then you can see here the Elasticsearch we could figure here. And we also have the Helm chart which we use to deploy our application. You know, here I got we expect after we deploy the application, we can reach to our application via this subdomain, and also like I mentioned before, we also reach to our ALK cluster via this subdomain as well. To choose that mm, connections, we need to have the ham chart with you to deploy our application, and also we need to deploy a full bit agent into our AKA cluster, and here the templates for Fluentbit, and we have some Fluentbit cluster row, log cluster binding, and Fluentbit config map it would use to make the connection file from the agent we install in the AK cluster. It helps to push the clock from it collect from AK cluster to the log tab we have in the ALK cluster. And of course, this is the daemon says this is the main components of the phone bit which is used to install in our ALK cluster. And you can see this is run as a daemon says, so that means all the service of the phone bit will be deployed into every node of the AK cluster. Of course, we have the phone bit service account because we can understand that phone bit running as a third party in our Kubernetes cluster. So for authorize the phone bit to be into our cluster, we need to create a service account here. We got to need to create a cluster row and cluster row binding for the authorized access into our AK cluster. And also, I would like to introduce you guys about our channel backend apps. And for this demo, we use the full stack, which has the backend and also the front end to connect together via Kubernetes service. And here the code structure for backend and crowd is we got the core structure for front end. And for front end, I use the Angular TypeScript. And for backend, I use Java. And for database, I use the MySQL. And with this the full stack, I think it's enough for to test the, the connection. And also we test the log for the the connection between the end user, and we try to monitor the log is keep in our application, and it can be visualized via Kibana and Elasticsearch and Logstash as well. And I also want to introduce you guys about the default config of the Nginx. You know, we containerize our front-end service into the Nginx platform, and we need to custom some dedicated configuration for the Nginx. And you will see here the default configuration. We try to add this message this because we need to have some scripts to simulate the testing. This means I want to put the traffic from the end user to the destinations, our hosting, and I will try to write some method here. So that's the reason why for the file format custom or the log, I want to write some message like this. And yes, for those kind of configurations after we got done, now you can see all everything got done of representing the infrastructure, and we'll try to make a quick test some for some those of the component to be to make sure all those is up and running. And before we get that, I would like to share you guys about the script. The script we use to simulate the user connect to our application. You know, we got here the subdomain which is used for user to connect to our application service, and we try to use the while loop like this and with message like this. And we expect one we run this script in the Kibana log dashboard, we will have some message to to demonstrate there's some connection from the host our application. Now we can get started to make the the verifying the order components is completed here is available or not. Alright, now we try to zoom into Azure portal and we try to refresh this. And when we refresh this, we will have some result groups which we created there. And this is the main result group. And in this result group, we have multiple many service like we see in our high level design here. And you see here we got the application gateway, we got the IP address of the application gateway, we got also the DNS join and private DNS join, and we also have the AK cluster here, and we also, because this is the settlement is a ELK stack, so we have the Elasticsearch VM, we have Kubernetes VM, or we also have the log.VM, VM, and also we got the VNet and some needed secure forest. For all the web component, we have used many port open. For example, for Kubernetes, we use port 5601, and for that dessert, we also use some port like 9211 or something like that. And now, before we get started to deploy our applications, we need to get the credential for the AOK cluster first by zooming into the created AOK cluster and copy this cluster credentials, and we back to our terminal and we pay on this and we copy this and paste on this and then drag enter. And now we can see I can authenticate with our AK cluster. And now we will start to run the installation our applications. For running the application installation, we just try ham installs, and I can install my application with name like this, vndev and DOS. That means runs or code at the current path. That press enter. Oh, you can install. Yes. We can wait for a while, maybe 30 seconds, and then so we can see the installation process is completed. And now you can see on the screen that means you already completed the installation. Now we can try to get the both. You can see the port is incorrect for running. You can start to watch for this to see the real time to make it happen with the issue or not. And now see you can see it's all running body completed. It got some restart, some service, but it's no problem here. We can make our application run and up. And you can see it is running for front end and MySQL, and now we're waiting for our backend to be run as well. Alright, now our thing is run up and running, and we try to zoom into our front end service, and we try to refresh this. Alright, see what work with the ELK service. It's here is the key Kubernetes dashboard. And now for our UI service, try to restore it to see it working as well. Alright, now our applications is also running up, and we try to input the credential to log in into my app first. All right, after I input the credential admin facility.vn and password chat blocking, it get now as our application is up and running and the admin user now is able to login into the application and we try to check the memo logs here. Yes, we got our memo logs up here. That means our application is running well. And also we see that our Kubernetes service also running well. And as I mentioned, we will try to run the simulate traffic that adjust like this, and by using the pass simulate adjust, and you see it is running in the background, and we are now ready to check to see the log uh, is processed in our application, and it can be visualized into the Kubernetes dashboard or not. So let's jump back to the Kubernetes. You can refresh. All right, now I see it working, and now we try to explore by my own, and we can discover, and we can create the data views. And first of all, I can set my name Tan Nguyen, and I set in that pattern log. Maybe we can copy here for a template log. That's with authorities like this. And of course, we need to type them to monitor as commands. And now we try to save this. And now waiting for a while, so we can see the logs happen here. And you can see a lot of log because I'm running with a loop like that. Why? It will stop it until I press the Ctrl C, so that means it's still run in the background. So let's jump back to this. And we try to refresh many times. And now let's see if we already have the connection. Yes, I think it goes here the AKS environment, and let's see if we already have the message. Yes, this one. This is the test hacking sending from Tanwi machine. That is exactly the message content we got from the trip. And you know, in the clock tab, it got also some groups. So that means we have a high advanced filter. So that means with the Kibana log here, I'll try to copy this this IP address. Let's imagine that one you got monitor your application. You need to know the strokes of the IP address when to connect to. So I expected it my public IP address. So let's check this. So yes, if you want to check your public IP address, you can use this page. What is my IP? .com. You will see here this is my exactly my IP address. And we come back with the select here the ELK dashboard. We see that's exactly the same the public IP address of my machine. Yes, here exactly this IP address is my public IP address. Let's try this one, and yes, this one is the same. All right, so now we already proved that our ELK stack can get the log from our AK cluster was running on this app, and or like we already mentioned about this is self-managed ELK stack, and it's on demand. We can use the LT cloud with support you to get a log in our AK cluster normally. But I think for every solution it got advanced as it got broad and core. So it's based on the demands or our requirement, we can choose the best solution for this. All right, thanks so much for your questions and see you next time for our next discussion. Thanks so much.